Here's our first lecture of Introduction to Algorithms. So, what's actually is algorithms? Algorithms are used to convert our problem solution into step-by-step statements. These statements can be converted into computer programming instructions, which form a program. This program is executed by a computer to produce a solution. Here the program takes required data as input, processes data according to the program instructions, and finally produces a result. Key characteristics of algorithms. For an algorithm to be effective, it should possess the following characteristics. Input and output. The algorithm must have clearly defined inputs and produce outputs. Definiteness. Each step must be clearly and ambiguously defined. Finiteness. The algorithm should terminate after a finite number of steps. Effectiveness. Each step should be basic enough to be performed exactly and in a finite moment of time. Generality. The algorithm should be applicable to a class of problems, not just a specific instance. Algorithm representation methods. There are several ways to represent algorithms, each with its advantages. So first, natural language, describing the steps using plain language. Flowcharts, visual diagrams that represent the sequence of steps and decisions. And third is pseudocode, a high-level description of the algorithm using a syntax that resembles programming languages, but it's more abstract. And here's the classification of algorithms. Algorithms can be classified based on the approach they use to solve problems. Like first, recursive algorithms call themselves with modified parameters. And second, the second one is backtracking algorithms. They try all possible solutions and backtrack upon failure. The third one, divide and conquer algorithms. They divide the problem into sub-problems, solve each sub-problem, and combine their results. First one, dynamic programming. Break the problem into overlapping sub-problems and solve each sub-problem just once. This one is greedy algorithms. Make the best possible choice at each step. And the last one is brute force algorithms. Try all possible solutions until a satisfactory solution is found. An efficient data organization is crucial for effective algorithm implementation, and here common data structures include like arrays. It stores elements of the same type type in a contiguous block of memory. Linked list. It consists of nodes, each containing data and a reference to the next node. Stacks follow the last in, first out principle. Queues follow the first in, first out principle. Trees it's hierarchical structures with a root node and child nodes. Heaps, it's specialized trees used for priority queues. The next one is hash tables. Use a hash function to map keys to values. And the last one is graphs. It consists of vertices connected by edges. And example for an algorithm. So let us consider the following problem for finding the largest value in a given list of values. So problem statement, find the largest number in the given list of numbers. And here's input, a list of positive integer numbers. List must contain at least one number. And output, the largest number in the given list of positive integer numbers. And we should consider the given list of numbers as L input and the largest number as max output. And here's the code. So our steps, our algorithm. First is define a variable max and initialize with O. 0. Step 2 is compare first number. It's like X in the list L with max. If X is larger than max, set max to X. Step third, repeat the step second for all numbers in the list L. Step fourth, display the value of max as a result. And a little bit about recursive algorithm. In computer science, all algorithms are implemented with programming language functions. We can view a function as something that is invoked, so called, by another function. It executes its code and then returns control to the calling function. Here's a function can be called by itself, or it may call another function, which in turn call the same function inside. It's known as recursion. And a recursive function can be defined as follows. And here's the definition. The function which is called by itself is known as direct recursive function or recursive function. Thank you for attention.